Hello and Namaste. In continuation with the Z transform, we are moving ahead with the another set of standard functions and the Z transform of them. So in this particular session, we are going to go ahead with the Z transform of n, Z transform of n into a to the power n, n squared, n into n minus 1, and the Z transform of t. Now, what is this Z transform of n? N means a number or a sequence you can go ahead with. So, you will be getting the sequence something like this. So, it is using the standard form, or you can say the definition of a Z transform. It can be written as n into z to the power minus n. N is moving from 0 to infinity, and which is same as after putting 1, 2, 3, 0, 1, 2, 3, 4, so on. We will be getting the series as 1 by z plus 2 upon z square plus 3 upon z cube and so on. After taking the 1 by z out of this particular series, we are going to get this type of series, which is nothing but the 1 by z into 1 minus 1 by z to the power minus 2. This is also one of the Maclaurin series, which is giving you the series something like this over here. If the mod of 1 by z is less than 1, that is mod of z is greater than 1, that means we are going to go ahead, or we are going to get this as z upon z minus 1 the whole square. After adjusting the terms, we are going to get it z upon z minus 1 the whole square as the Z transform of small n. Then Z transform of n into a to the power n is nothing but using this differentiation of z domain. So Z transform of n into f of n is equals to minus z d upon dz of f bar of z. That means this is nothing but after, if you are multiplying with n to a particular series or particular function, then it is it can be written as minus z d upon dz, z to the power minus a to the power n. And we have already seen the Z transform of a to the power n in the previous part. Please follow the I button to reach to the particular part, which is minus z d upon dz of z upon z minus a, which can be written as, which can be done after the differentiation of this particular z upon z minus a. You can just go ahead with the u by v rule of this particular. So z minus a into the differentiation of z is 1, minus z into differentiation of this z minus a is equals to 1, and divided by z minus a the whole square. That can be written as, or just by adjusting the terms, you are going to get is az upon z minus a the whole square, where the ROC is mod of z is greater than or greater than mod of a. Now Z transform of n square, that is Z transform of n into n, that is z minus z d upon dz of z to the power z of n, and we know that just now we have seen this is nothing but the Z transform of n, and going ahead with the same what we have done it in the previous case, the same way we have to go ahead, and you will be getting it z into z plus 1 upon z minus 1 the whole cube as the Z transform of n square. Similarly, if you go ahead with Z transform of n into n minus 1, that is Z transform of n square minus Z transform of n, because of the linearity property of the Z transform, and you can just check it from the previous slide that Z transform of n square and Z transform of n, both the things we have already found it out, and therefore after the multiplication and everything, we'll be getting the Z transform of n into n minus 1 as 2z upon z minus 1 the whole cube. So here we have used the property or a linearity property, the property of linearity over here. Then Z transform of t is equals to Z transform of n into capital T. That means it's nothing but t is a constant, t is coming out of the z because of the again the linearity property, t into z to the Z transform of n, and therefore this is nothing but tz upon z minus 1 the whole square. That means it is nothing but into the Z transform of n, what we have done it over here in this case. This is nothing but, and this is because of this particular t, small t is nothing but nt, because of this fact which we have already seen in the previous cases. This is all about the standard functions, the Z transform of a standard function part 2. Stay connected, stay tuned for the upcoming sessions of the Z transforms. Thank you. Happy learning.